Hi, boys and girls. We're going to be doing lesson 9.3 today. This is analyzing relationships. So our essential question today is, how can you use the strategy find a pattern, okay, to solve problems involving relationships between quantities? All right. So basically that means I'm going to take a table like I'm boxing right here, and I'm going to analyze what is happening from X, or the top, which is usually X, to Y. What's going on from the X variable to the Y variable? I'm going to have to use some thinking skills. So as you're doing this, you're going to be looking at multiply or divide or add or subtract. You're going to be using one of your operations in every story problem that you're working with in this lesson. So let's read the question to see what this actual question is about. It says the table shows the amount of water pumped through a fire hose over time. If the pattern in the table continues, how long will it take a firefighter to spray 3,000 gallons of water on a fire using this hose? Now, when you're looking at this chart right here, it says fire hose flow rate. The title always tells us what's going on. Oops, then over here on the side, sorry about that, boys and girls, it says time. That's my independent variable. My dependent variable is the amount of water. So I'm going to solve for this, the independent variable. So we need to think about the first thing you're going to do is you're going to be looking at the relationship from X to Y. So I'm going to take a moment here and I'm going to pull up for you this little chart that's in your book. So let me make this a little bigger. Get my computer to do as I say today. And it says here, what do I need to know to start out? What do I need to find? Well, it's asking me to find the time takes for 3,000 gallons to spray from the hose, okay? The time that it takes. That's nowhere near what one of these are. So I don't want to make a table that's going to go around my living room here and back. So I'm going to have to do some math to figure it out. All right, I need to use the relationship between time and the amount of water to figure this out. Okay, between time and the amount of water to figure it out. So let's look over here and solve the problem side. It says, use the table above to find the relationship between time and the amount of water. Think. Let T represent time in minutes and W represent the amount of water in gallons. The amount of water in gallons is what? Multiplied by the time in minutes. Look at your chart. I have 1 to 500, 150, 2 to 300. So in actuality, I'm just going to give it to you. It's going to be 150. See if I get this to change. It's going to be 150 multiplied by the time in minutes. So we're going to say, instead of using X and Y, I wish they would do that. I'm going to use what the book does. We're going to say W is going to be my dependent variable, is dependent on the fact that it's a constant of 150 times the time. Okay? It's 150 gallons times the time. So each minute. Okay? So in this case, I know that it's 3,000 gallons. They're giving me the dependent variable, not the independent variable, guys. So this makes it more complicated. Here's my formula. W is equal to 150 times T. So this time I have the dependent variable, the answer, but I can still solve this because you know how to solve for T. Okay, so instead of multiplying, we're going to divide by 150 on each side. Sorry, that doesn't look like a 0. Okay, and I'm just going to give you the answer today because of time. So when I take 3,000 and I divide it, okay, 3,000, and I take 3,000 and I divide 3,000 by 150, I'm just going to give you the answer. You're going to end up with 20. So the answer is it will take 20 minutes to spray 3,000 gallons of water. Okay, just to go back, I had to analyze between the independent variable and the dependent variable to find out what my equation will be. Okay, let's do another problem quickly. Turn the page, please, to page 504. Okay, it says dairy cows provide 90% of the world's milk supply. The table shows the amount of milk produced by a cow over time. If the pattern in the table continues, how much milk can a farmer get from a cow in 1 year? Now that's 365 days. Make sure that your variable is representing the same amount of measure, okay? All right, my independent variable is time, which is X. My dependent variable is milk output, which is Y. So I have to quickly determine what's happening from my X to my Y. We've been doing this on STMath. Many of you have just been finishing up this particular unit right now. Okay, so if I'm going to go from 2 to 50, 7 to 175, I'm not going to take the time to talk this through because it will take too long. But basically, what you guys have is Y is going to be equal to X times 25. Okay? So if I change the time, okay, the amount of days, then I'm going to know what my output is. So my problem says 365 days. So I'm going to take Y, and it's going to equal 365 days times 25. I'm not going to sit and do the math with you today because I don't have time. It's going to end up that Y is going to equal 9,125. Are you following me so far? Okay. This is kind of a tough lesson because you're going to have to really think about the patterns that you see and start to be able to analyze what's happening between the X and the Y variables here. Okay. Let's pull up one share and show, and then I'm going to let you guys work on these on your own. Okay. We're going to use right here, this table. You see this table I'm circling? Okay. Your shirts are going to be your independent. It's always on the top, and the dependent's usually on the bottom, okay? Let's read the problem. Looking at the pattern in this table to solve this problem. A soccer coach is ordering shirts for the players. The table shows the total cost based on the number of shirts ordered. How much will it cost if the coach is going to order 18 shirts? Okay, this is what I'm going to use to substitute. Okay, I'm just going to put the word substitute. Okay, first of all, we got to find the pattern and write the equation. Okay, you understand? We're going to find a pattern so that we can write this equation. So the cost is $15 multiplied by the number of shirts. Okay. So the shirts, this is my X. And what's going on from X to Y? What's going from here to here? 2 times 15. I'm just going to give it to you. We just don't have time to be thinking, well, what's happening from X to Y in this video? We'll spend more time if you're listening to me teach it. So I've got the dependent variable, which is the cost, is equal to 15 times X. Okay, that's my formula or my what is going on. I guess in this case, they have it as N. I'm sorry, should have put an N. Oh, well. Okay, so now we're going to take that equation. We're going to find out what 18 costs. So let's do some substitution. We're going to take C is equal to 15 times 18 because I'm going to substitute for that X right there. Okay, so C is going to equal 270. So the cost of 18 shirts is $270. All right, boys and girls, today we looked for a pattern from the X to the Y, or from the independent to the dependent, whichever table we had, to write an equation. All right, thanks, boys and girls. Happy math.